Hello, I'm Ishaan Agrawal.
And I'm Jivesh Sharma.
We're the developers of Hemo Analytics application.
Blood tests are an integral part of modern society. They're regarded as a standard convention within the world of medicine and health.
They're utilized as a means of identification of a range of diseases, spanning from diseases such as leukemia to anemia, diabetes, and many, many more.
A CBC test, also known as a complete blood count test, is currently the most commonly used blood test globally. Thus, it was the focus of our application.
It's no secret that doctors, nurses, and medical staff around the world are worked to the bone.
However, an issue that arises with that is the occurrence of occasional errors within the diagnosis that medical practitioners provide to their patients.
While human error is inevitable, a misdiagnosis in the world of hematology is not something to be taken lightly.
Patients usually do not have the means to interpret their own blood tests. To them, it's nothing more than a set of numbers on a piece of paper.
However, our solution solves both of these problems.
Our prototype is an application containing 4 independent algorithms. 3 of these algorithms can be utilized by patients, whereas all 4 can be utilized by doctors. Firstly, we retrieved datasets from Kaggle, which is a popular machine learning website, and pre-processed the data by normalizing all the values between 0 and 1 using sklearn and OS for file manipulation.
Next, we built the neural network models using TensorFlow's API, which is a framework for machine learning.
The structure of the anemia and diabetes neural networks can be seen here. There are 5 input nodes, followed by 3 hidden layers.
The first and third layer of the neural network consists of 128 neurons, with the second layer consisting of 256 neurons. Each hidden layer has a ReLU activation function.
The last output layer has a sigmoid activation function to return values between 0 and 1, determining whether the given inputs lead to a diagnosis of the disease.
1 corresponds to a positive diagnosis, whereas 0 corresponds to a negative diagnosis.
Next, we have the structure of the leukemia algorithm.
We used around 2,000 images in the training phase of this algorithm, and we utilized the VGG16 model, which is a pre-trained model trained on ImageNet dataset, a collection of over 14 million images belonging to 22,000 categories. This makes the VGG16 model ideal for classification problems.
We flattened the output of the model to trainable dense layers, followed by a single output, which then passes through the sigmoid activation function to return values between 0 to 1. This is the general model we used for the anemia and diabetes algorithm. You can see that we have 2 models saved at the bottom. These ones received accuracies of upward of 90%.
The code on the left sends the request to the backend and awaits the predictions. As you can see, I have a sample response which has a really high probability of giving anemia. The model also predicts this, as shown right now.
This is our general leukemia algorithm. Over here, you can see that we have joined the VGG16 model with 2 trainable layers with the final layer, giving us a probability of leukemia.
As you can see, when an example positive result is submitted into my app, the accuracy yielded matches this claim. As you can see, the accuracy matches this.
Lastly, our general CBC algorithm takes in the user's age and gender alongside numerous other CBC values to determine whether they are inside or outside a given range.
This is our final application, and its accessible and user-friendly design allows for a smooth and effortless experience. This not only improves the user experience, but prevents careless mistakes when inputting results. As shown when I try and input this number 33. It's very effortless.